Hello everyone. In this week we will start you a topic about the Python programming language, which especially including the some utilization library for the engineering application. For example, the Seaborn Library, CGPy, or the filter, or the statistical analysis, or the numerical integration, or the oscillatory system modeling. In what? In Python programming language. And so in the first place we need to create the Seaborn Library .py examples in order to do that. Okay, and so firstly we need to give the some head title in here, like this one, utilizations. What's Seaborn? Seaborn is a tool for visualizing any data which are generated from any measurements or algorithm. Okay, and so this Seaborn is based on the what? Based on matplotlib library to visualize your results in a proper way. In engineering application, especially for the data discrimination or the data representation, we need to analyze the whole data. But in order to create the more beautiful or the meaningful data representation, and then we need to give some visualization tools to represent whole the data in a clear way. Okay, and so Seaborn is utilized mainly for this purpose. Okay, so in the first place we should give the head title in here, like this one, the x1, visualizing statistical distributions or kernel density. Okay, in order to do that we need to give the some import Seaborn as SNS, and we should also import the matplotlib.pyplot in here as PLT and also we need to use the numpy as MP. Okay, so in the first place we need to generate some sample data in here, like this one, data mp random dot normal distributions can be given in here, and also we should give the size 1000 in here, and so this code generates the 1000 data representing the normal distribution of the Gaussian model. Okay, and so for the Seaborn application we need to give the SNS set values in here, like this one, and so the style can be assigned with the for example the white grid. Okay, and so this is the utilization of the Seaborn in order to in order to create the more appropriate figures or the tables. Okay, after that PLT figure can be assigned with the fixed size of the 8 and 6, and SNS histogram plot can be utilized in here with the data, and bins can be assigned in here, like this one, and so this bins indicates to the how much area contains the different variable or the data. For example, if I choose the bins is equals to the 30, and which means that we can assign the one bar into the 30 data in here. Okay, hist plot is given here, and after that KDE is true, and color is assigned with the sky blue. Okay, and so PLT title can be assigned with the histogram with kernel density estimation. Okay, so this KDE represents the kernel density estimation in order to in order to represent the whole data in the histogram plot diagram. Okay, and PLT X label can be assigned with the value, and PLT Y label indicates the frequency of these terms. Okay, And after that we should show the whole data in here. And so if I run this code and then we will have the figure in here. I'm waiting. Okay. And so this histogram data represents what our nomination for the Gaussian normal distribution function. Okay, and so we have the 1000 data, and so each bar represents what the data representation or the distribution on this diagram. For example, the mean value is equals to what the zero value, and we have the standard deviation value in here, and then we can get the what the KDE is true in here. Because if we have this distribution and then the SNS or the Seaborn library returns to the what the automatical values of the what these distributions. For example, if I choose the location, for example 5, and STD or scale value is the 5.2, and then if I rerun this code and then we have the 5 value in here like this one, but we have the different Gaussian distribution model in here in terms of the what our nomination. Okay, for example, if I choose the scale is the 100, and then which means that we distribute the whole the data in the what in the this upside and downside values in here like this one. And so we have the represent data between in the what the 5 mean values, and then we will have the what the 100 standard deviation data, which means that we have data at the 300 and the minus 300. And so this distribution expands in the what in the values of these terms. Okay, and also we can assign to what the KD is false, and this represents to the what we have only histogram data is given in here. Seaborn Library returns automatically what the Gaussian distribution parameters to what to visualize the whole the results in here. But if I choose the what the true values, okay, and so this beans value may be assigned with what the 100, which means that we have the some small number of this data in here. Okay, I'm sorry, Faruk. Okay, and so I stop sharing, and screen 1 and 2000 bins can be given in here like this one. And so you can see right now. Okay, and so these 200 bins, which means that we have 200 section in our normal distribution, which means that we have the 200 bars in here. Okay, or we can assign to the what the 5 values in here like this one. And so we have 5 histogram diagram in here, but our kernel density estimation is not appropriate for the what for the estimation of these algorithms. Okay, and so you need to find out the what's the best values of the bins parameter in here. You have the higher value in the bins, and so this includes the what the some noisy parameters can be included in this model. But if I choose the what the small number of the bins, and we have the what the incorrect form of the Gaussian distributions in here. Okay, so this is the histogram data representation. Okay, so this may be 30 values in here. So the next example, we will talk about the pairwise relationship or pair plot. It's given in the what in the Seaborn library. Okay, firstly we need to add the same here Seaborn as SNS and import matplotlib.pyplot as plt and import numpy as mp, import pandas as pd. Okay, and so in order to set the general property of these terms, like this one, style should be assigned with the text value, and color codes must also be given as the true. Okay, and after that we can generate the synthetic data. mp random seed value can be assigned to 0 value, and n samples should be given in here, and features should be given as the 3, and categories is equals to 3. Okay, and after that we can generate the data in here, like this one, data mp random rand with the n samples and n features. Okay, we have the 3 categories and the 3 features to build our synthetic data. Okay, and after that we can assign the category data, or the labels, correct meanings. Categories can be assigned with the mp random choices in here, like this one, category 1, category 2, category 3, and we should assign the n samples, which means that we have the 150 samples in here, and so each sample should be contained with the category 1, category 2, or category 3. Okay, and after that we can create the data frame by using the pandas library. Okay, and so features names can be assigned with the feature 1, feature 2, and feature 3. Okay, and df pd data frame this is the standard function to build our data with the columns values of the features name, which means that we have 3 features, x1, x2, and x3, and so this data frame can be built by using the pd function, and then we can select to each data within each feature to category 1, category 2, and category 3. Categorize the values by using these terms. Okay, and also we can give the category in here, like this one, assigns the categories. After that we can use the Seaborn library to plot these features, plt figure, fig size 10, 8, and SNS pair plot is utilized in here, and so this df or the pandas data or this data frame can be fed into directly into the SNS library or the pair plot library to build the category color codes. Okay, and after that plt sub title can be assigned with the pair plot of synthetic data, the ratio of the 1.02. Okay, and also we should give the plt show in here, and so if I run this code, and then we have the 3 data in here. For example, feature 1 can be built with this data representation, feature 1, feature 2, and feature 3. And so this is our normal distribution to build each data in a proper way. Okay, and so we have 3 categories, and so we have the 3 color codes to build this data representation. And so how can we utilize this term in the engineering application? For example, if you have the 3 features, x1, x2, and x3, and then if we have the 3 class values, category 1, category 2, or category 3, and then this pair plot directly represent to this data distribution in order to compare our data with another one. Okay, and so this highly useful technique to create the classification problem in data manipulation. Okay, This pair plot is directly utilized for these purposes. And so, in the third example, we should show the heat map for correlation matrix. What is heat map? In the example, I will show you this property in here. Import matplotlib.pyplot as plt and import numpy as mp, and we can generate the new data in here like this one. Data mp random dot rand function within what 10 12, and Seaborn Library can be utilized with what the figure values, fig size 6 8 6, and SNS heat map can be utilized with what data and annotation is true, and CMap is assigned the cool warm values. Okay, so PLT title can be assigned with what the heat map of a random data set can be given to what the PLT show values in here. And so if I run this code, and then we will have these values. For example, in the heat map generation, we have the sum data. It's given in the what normal distribution values, okay, 10 12, okay. And so we have the 12 and 10 value, or the 10 heat map is given here, but internal of this value is equals to what 0.91 or 0.12 or 0.44. okay. So this matrix 10 times 12 matrix is assigned with the what the blue or the red values, which is scaled with the what up these values and this one, okay. And so if we have the 0 to 1 value in here, and then we can see that these values contains the what the heat generation in here, or the highest value is assigned with the red, okay. And so we can easily check this data by using the heat map, because this is more visualized terms of the what random data set. But in your application or in your engineering application, you can utilize to what to easily see the what is the highest values, or the what is the distribution of the this data or your data for a given to the what to your application. For example, if you have this data in here like this one, and so if we have the red generation in here, or if we rerun this code like this one, and so we can easily see the what's the best feature in here. For example, we have the highest value in here, and so we can easily see that, or we have the highest value is in here, we can easily see that, which is why we need to use the heat map of the data representation, okay. The Seaborns automatically generate this correlation matrix for the what for any data. So in the fourth place, we should talk about the time series visualization of the data line plot, okay. Import Seaborn as SNS, import matplotlib.pyplot as plt, import pandas as pd, and import numpy as mp should be added in here, okay. And so creating the time series data based on the what random numbers, okay. For example, mp random seed value can be assigned 42. For example, the dates can be created pd date. Range function returns to the what the r values of the what this term. For example, 2021 1 January can be assigned in here, and we can also set the periods in here like this one. After that, we can generate the what the pd data frame in here. mp random rand and number 102 matrix is given in here, and index as the dates in here, and so we can assign to the whole the dates into the what to this random vector in here, and then we should give the columns value in here like this one, the A and B. Okay, after that the Seaborn can be utilized. PLT figure in here, fixed size 10 and 6, the row and column values of these terms. SNS line plot can be utilized in here. Data must be equal to the data, and palette of the what the tab 10 and line white is assigned to dot 5. Okay, and PLT title can be assigned with the time series data visualization. Okay, and also PLT show must be given in here. And so if I run this code, and then we will have the data values, but in the data values we have the what the 2021 0101, 1 January, 15 January, 1 February, 15 February, and 1 March, and 15 March, and goes on these terms. Okay, and so also we have the two kinds of data, A and B, as a PD frame, which means that we have the random values of the A and random values of B can be assigned in here, but in this term we have the what the time series data, or dates of these times. Okay, and so this line plot directly returns to the what our generations, or our format of this what these terms. Okay, and so if we have the x values or the x label in terms of the what the number or string character, or the date, or the what the person name, for example, and then we can easily set or use this line section by using the what the Seaborn library. Okay. So after that we should continue with the categorical data visualization box plot. Okay, so for the box plot, what's the basic of these terms? Import Seaborn as SNS can be assigned in here like this one. Import matplot lib.py plot as PLT, and import numpy as MP. Okay, and so generate random or sample data in here, MP random seed 10 value, and data can be assigned MP random dot normal value with the size of the what 20 and 6. Okay, after that we should plus MP arrange values with what the 6, but this random value MP arrange 6 divided by 2 can be assigned in here, because we need to add some bias values on this term in order to what, in order to efficiently see the advantage of the box plot. Okay, and Seaborn library can be created with what the figure fixed size 6 and 8 and 6. SNX box plot can be called with the data and PLT title box plot for categorical data. PLT show must also be used in here. Okay, and so if I run this code, we will have the what the sum data generation. Firstly, you need to see that we have the what 20 values in here. Okay, but we have the 6 column values, and we have the 6 column values at the what at the X label. Okay, but we generate what the 20 values for each pair. Okay, and so this box plot, for example, for the 0 in this, and we have the 20 data, and this data represents to what are mean values and the standard deviation of this data, or the random distributions on this data. And so this box plot returns to the what are data generation and this the standard deviation values on these terms. For example, if we have some different data, and for example in the 2 or the second column we have some data like the 1.1, 1.2, 1.11, 1. Blah blah blah, and so this data is represented in here, but in terms of the box with the mean values and the standard deviation of these distributions. Okay, this is highly useful in order to represent your error case or the error operation in your statistical analysis. Okay, just remember that this box plot returns to some useful information about the generic representation of your data plot. Okay, so in the 6th example we need to talk about the scatter plot for regression line. Okay, in your ML application or machine learning application or the artificial intelligence used based or the algorithms, you must utilize the scatter plot for these distributions, and the regression line must also be given in in this domain. Okay, and so if we have any model represent your data, and then we can regress to your data in order to build our model or the line. Okay, and so this scatter plot represents some points on your figure or on your data, but the regression line returns automatically to model this parameter. For example, in order to clarify this example, we should add the matplotlib pyplot as plt and import numpy smp generating sample data mp random seed value as 0, x can be assigned mp random dot rand function 100, and y is assigned 2 times x plus mp random normal distribution with the 0 mean and 0.1 standard deviation and 100 data. Okay, and so we add some noisy inputs in order to generate our sample data. And so how can we utilize or how can we visualize these terms? By using the Seaborn scatter library. SNS set can be assigned with the style as the dark grid instead of white grid. Okay, and plt figure can be assigned with the fixed size 8, 6, and SNS rect plot can be called in here in terms of the x input parameter, y output parameter. Okay, and plt title can be assigned with the scatter plot with regression line, and plt x label can be assigned as x and y, and plt show can be used or show the whole the results in here. Okay, and so this regression line creates this model. This blue line represents our regression line for a given data, which is given in the scatter plot diagram. Okay, for example, if I choose this one values in here like this one, and so we have the higher values noisy parameter in here. Okay, for example these terms, and so our model or our regression line returns to the best fitting curve or the line to represent this data. Okay, and so if I choose the smallest error values or the standard deviation in the noise values, and then we have the strictly proper modeling in here, like this one. This curve, this line is best fitting for the what for our data generation, but with small random noises is given in here. Okay, so this is how we can use the what the scatter plot and the regression line in Seaborn Library. Okay, especially for the machine learning application, you must utilize the what the scatter plot effectively in order to represent your data by using the what the these terms or the represent the this visualization technique or the data representation in an efficient way. Okay, and so violin plot must also should be given in here for the distribution or comparing your distributions. For example, the import Seaborn as SNS can be assigned in here. Import matplotlib pyplot as PLT can be given in here, and import numpy as MP. What's 100? 100 is the size of your data. For example, the MP rand returns to what 100 times 1 vector, and so this 100 represents to what the 100 noisy values on your application. Okay, Abdul? Okay, so firstly generate random data or MP random seed must be changed with the 42. For example, data MP random normal distribution can be used in here, like this one. This size represents what 103 vector or matrices, which means that we have the 3 columns and 100 rows at this location, and so our mean values or the location values is equals to what the 0 values, and our scale values or standard deviation values for this normal distribution is the 1. Okay, and so we can create the categories MP repeat in here, like this one, the A, B and C, and after what until the repeating is reaching to what 100 values. Okay, and so A, B, C are categories for the 100 data, and so we have the 3 kind of data in here, but we can assign to what a 3 class or 3 categories in here. Okay, and so what is violin plot? SNS set can be assigned with the style value in here, white grid, and PLT figure is assigned with the fixed size is equal to the 86, and SNS violin plot X equal to categories. Okay, and Y is equal to data flatten values. Okay, what's the meaning of the flatten? Flatten means that if we have 100 times 3 matrices in here, this flats hold the data. For example, this 100 times 3 matrix converted into the what 300 times 1 vector. Okay, and so this size or this matrix converted into the what the one-dimensional data. Okay, and so PLT title violin plot for comparing distributions, and after that PLT show can be given in here. Okay, so what's violin? What's violin plot? Violin plot means that in the A data we have this kind of flatted data in here. For example, up to minus 0.5 to 0.4. Okay, but this violin data represents what comparing the R distributions, and so these values in here, like this one, are distributions, symmetrical distributions in here. Okay, and so in order to understand the representation of data or data distributions, and so this violin plot means that we have some normal distributions, but in the second plot we may have what the greatest number of these terms in here, like this one. And so we can easily see that the difference between the A data and B data. Especially for the C data, we can see easily that we have the highest values or the lowest values in here, like this one. But this data is not distributed as a normal variation. And so we can easily compare the whole distributions by using these terms, because if the A data distribution is similar with what the B data, and so these two plots is closest to each other, but we can see the basic differences by using this violin plot in here. Okay, so and now take a 10 minutes break, and after that we will continue with the bar plot and the phase grid multiple plots in the Seaborn library. After that we will continue with the CGPy optimization techniques for the data. Okay.